Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. Today we are going to do a very important lead code problem, Decode Ways, and this problem has been asked in a bunch of different FAANG companies like Amazon, Google, Facebook, Microsoft, Uber, Lyft, Apple. So I highly recommend that you focus full attention to this problem. This is the breakdown that we are going to do for this problem. We are simply going to understand the problem first. We are going to see a brute force solution. Based on the brute force solution, we are going to see that how can we create an optimal solution, and eventually we will write the Java code for that. And this is a LeetCode medium problem, and we are given a note that basically a message containing letters can be encoded into numbers using the following method. So A is 1, B is 2, and up until that, if we keep doing that, Z is actually 26. And we are given a string of S that contains digits, and we need to return the number of different ways we can decode it. So let's understand this with an example. Suppose our given input S is equal to 12. We can decode this in two ways. So one way to decode this would be to consider 1 and 2 as separate elements, and 12 by itself as a single digit. So this the value for 1 and 2 would become A and B using this logic, and the value of 12 would become the letter L. So we don't need to return these values, we don't care about them. The thing is, we need to return that how many different ways we are decoding this given input string, and in this case the answer would be 2. Let's take another example. So suppose our given input S is equal to 226. How many times, how many different ways we can decode this one? So one way to decode this one is 2 and 26. So that's one way. The second way to decode this one is 2 or 2 and 6. So that is second way. And the third way to decode this one, 22 and 6. And if we check out the values, so this would becomes B Z, this would becomes B B F, and this would become V F. So over here we can see that there are three ways we are decoding this given string. So in the answer we will return the value as 3. Now let's consider one more case. Suppose the value 0 would be a special case, and there could be multiple possibilities where 0 can appear. So suppose our given input S is something like 0 1 1. So in this case we won't be decoded in any manner, because remember that our range starts from this value number 1 up until 26. So 0 is not part of the range, so we cannot begin our string with value 0 at the beginning. So this won't work. Second possibility, that 0 could be somewhere in the middle. So suppose our given input S is equal to 1 0 1, something like this. So in this case we cannot decode this in 1 and 0 1. We can't do this. Why? Because we can't decode this 0 1, because remember that in this scenario, if 0 comes at the beginning, we can't decode it. The way we can decode this is we can consider this as 10 and this as 1. That value of 0 can appear at the end. So our input string S can be something like 2 0 0. So in this case we can decode this value 2 0, but we can't decode the 0, so we won't be able to return anything. Or our value S can be 5 2 0. So in this case we can decode this. We can decode this value 5 and we can decode this value 2 0, because 2 0 is again between 1 to 26. But if we are given something S is equal to like 5 7 0, we can't decode this, because we can decode this 5 but we can't decode 7 0, because 7 0 is not part of this 1 to 26 range. So when value 0 comes in, it becomes a little bit tricky and we have to just take care of it. For brute force approach, let's take a custom example. Suppose our given S is equal to 2 1 2 3, and we need to see that how many different ways we can decode this one. So brute force approach is pretty simple. We just take all the possibilities starting from the first value and keep moving and keep building our solution, and when we reach at the end at any given path, we consider it as a one way to decode it. So initially we can decode this as 2 and whatever the remaining value 1 2 3. We can decode this further into 2, 1, and whatever value remaining. Again same thing, 2, 1, 2, and this 3. And in the end we can decode this as 2, 1, 2, 3. So this would be one way we would be able to decode this. So where if we treat all the values as separate entities. Now let's go back and see that can we have more possibilities. So over here we cannot have any more possibilities because this 2, 1 and 2 are already being decoded, and this 3 we only have one possibility to decode it by itself. So we don't have any possibility over here. So we go back further up. Do we have any possibility over here? So yes, over here we still have possibility that we can decode this 2 and 1 the same way we have decoded over here, but this 23 we can decode it as a single value. So of course we reach at the end of the loop. So this is one more possibility on how we can decode it. Now let's go back. So for this value 123, of course we still have more possibilities, because over here we are considering this value as 2 and 1 separately. So over here we will consider this as 2 as already being decoded, and rather than considering this as 1 as separate character, we can also consider it as 1, 2, and then we can decode 3. So this can also be another way. So we'll just mark it. Okay, now we have exhausted all the possibilities over here. Considering this value, if we start from this value number 2, so we come back at our main point, and let's see that what are the more possibilities we can have over here. So we can do, rather than choosing 2, we can choose 2, 1, and whatever the remaining stream. So remaining is 23. Okay, now let's see that how many different possibilities we can have over here. So we can have two possibilities now. We can do like 21, 2, and 3. So that is one option. Or we can do 21 and 23. So that is second option. And yeah, both would be separate ways. And apart from these, we cannot make any other possibilities. So essentially we can say that there are 5 different ways to decode this 2123 string, and those 5 ways are mentioned over here. What is the problem with this brute force approach? Well, the problem with brute force approach is that actually we are doing a lot of repetitive work. How we are doing repetitive work? If you notice over here that we know that we need to calculate that for this 23 how many different ways we can compute this one, but this 23 we have already computed it over here. So since we have already computed it over here, it is not very fruitful to compute the same thing twice, and in brute force we are not doing it. So that is why our path will keep on growing and growing until we reach to our all the possibilities, which means that we are actually doing exponential work for this brute force approach. So of course the time complexity would be big O of 2 to the power n, which is really bad, and we should avoid it in all cases. And actually it can be avoided pretty simply. If we just use memoization, if we just create an additional data structure, something like an array or something, where we store the value of calculations that we have already done, and if we at any point come back to the same calculation that we have already computed, we can simply return that value. So we can use something like an array or hash map. I think hash map would be more efficient in this case because we are able to look up things in constant time. And if we only apply that, we can actually implement this solution, this brute force solution, in very effective manner. We can actually use recursion because remember, at every single moment we are repeating a sub problem. So we are repeating a sub problem and we are computing that. So if we just use memoization with recursion, so for this approach, we can actually achieve the answer in time complexity of big O of n, rather than this 2 to the power n, and that would be really efficient. Okay, before I go into the optimal solution, I want to show you a few observations. Suppose our given input s is equal to 7. So how many different ways we can decode it? Of course, only one way, we can just use 7. Suppose our input is 7 7. We can still only decode it one way using like 7 7, and that would be the only way we would be able to decode it. Even if our value is 7 7 7 7 7 7 7, whatever the value we have, all of these can only be decoded just one way, because all of these values, they are forming a value where we can only use individual characters. Now, what is the scenario where we can use the characters that are not individual and we can collectively use the pair of elements? Okay, now let's take one more example. S is equal to 2 1 2 3, and now let's try to see that how many different ways we can decode this one. This is the same one we have used in our brute force approach, so we know that there are 5 different ways we can decode this one. The thing is, we are going to do things a little bit differently over here. We are going to decode all of these values. So first we'll start with value number 2. How many different ways to decode this one? Only one way, and that way is 2. Now let's consider the second value, 21. How many different ways to decode this one? Well, of course, two values or two different ways, and those ways are 2 1, so that is one way, and second one is 21 by itself. And let's take the third value, 2 1 2. So there are actually 3 different ways to decode this one. Let's consider the next value as 2 1 2 3. So we know that for this one there are actually 5 different ways to decode this, and the 5 ways are, okay, you must be thinking that why am I writing all these letters? Because the thing is, there is actually a very important relationship that exists whenever we find out, whenever we add a new value to our calculation, and if that value that is being added, if the previous value of that with that particular value, if that falls between this 10 to 26, actually something interesting happens. So notice over here that this 21 came in. Okay, we are checking for this value number 21. Now the thing is, just for a second, imagine if this value was actually 27. So how many different ways would we be able to decode this one? Well, only one different way, and that one different way would be 2 and 7. So treating both values as separate values. Same goes for 28, 29, and any value above. But the thing is, because this value falls between this 10 to 26 portion, we are able to do something interesting. So notice that whatever value we append over here, there will always be one way to decode it. I'm not talking about the value 0. Forget about 0. Apart from 0, if there was any other value, the way to decode it would be to whatever the way we have been decoding the previous value. If we just add that value, then that would be the way to decode it, which is over here. That 2 and 1, we are already decoding it with whatever value we were decoding before, and we were using that way. But the thing is, over here, this 21 by itself falls under this 10 to 26, which means it is a letter by itself. So we are able to add it to our decode list, and that is why we have 2 over here. Okay, but now the interesting part comes in. Okay, now over here we are adding one more 2, and this 2 falls between the values 10 to 26, because the appending value becomes 12. So this 12 falls between this 10 to 26. Now let's see that how many different ways we are creating the pairs. Actually 2 1 and 2. This is same from whatever the pair we had before, just one iteration before. Okay, now this 2 1, we already had a 2 1 over here, and we are just appending this value 2 over here. So that is also okay, because we can append it, right? So whatever the ways we were decoding before, we are still using those ways. But the thing is, over here something interesting happens, because this 1 2 by itself is a way to decode. We are actually able to create this 2 1 2 pair, which we were not able to generate over here. We are not able, I mean, we are using this 2 over here, but the thing is we are using it for 2 1, but we can't do anything further than that. We are already also using this 2 1 2 over here. And how can we say that we are using this 2 1 2 over here? Is because this value is basically 12, falls between 10 to 16. But the thing is, this 2 actually comes from the first value, this one. And why? Because at any given moment we find out that there exists a pair with the new value being added, and that comes between this 10 to 16. We can actually do sum of previous two values that we have calculated so far, and the sum of these two would actually give us the number of different ways we can actually decode this one. If you still don't believe me, let me show you with another example. Let me clean this up a bit. Now over here we are seeing that 5 distinct pairs are being made, and we are adding a value 3 over here, and we know that this pair 23 exists between this 10 to 26. So that is all okay, right? We know all of these stuff. Now let's see that how many different ways we are generating the pair. So one way is 2 1 2, and we are just appending 3. This would be the case even if the value was 2129. If the value was 2129, we would still be able to use this way, because apart from this 3, there would be a 9 over here, but that's not the case right now. But the thing is, we would still be do it. And if you look over here, this is the same path we were taking, and we are just adding one more node, so no impact on the number of results. Second pair we are making is actually 21 2, and we are appending 3 over here. Again, that is the case over here, that we already had a 21 2, and we can append 3 over here, so that gets taken out over here. If we had the 21 29, we would be appending 9 over here, so that still remains common. Okay, there are no issues with that. Now next pair over here is 2 and 12. So we also have a 2 and 12 pair, and we are adding a 3 over here, which means that even if we had this 9, we would still be adding 9, and that would be it. We don't care about it. But the thing is, if we had this 9, we won't be able to generate these two pairs, because notice in these two pairs we are actually creating an additional value by the value that has added over here. And if this value was not between this 10 to 26, this value would not be able to be generated. Okay, now the question comes that we have already exhausted all the possibilities over here. So where does these two additional values comes from? Well, actually, if we look above over here, this one is actually 2 1, right? So we are also using 2 1, and we are creating a new decode node 23, and we are appending it over here. Also notice over here that this one is 2 1 and this one is 2 1, so we are appending a node over here 23, which means that at any given location, if we want to see that how many times we can decode it, if we know the information of previous two elements, and if we do sum of those, we can actually generate it. So that's why the value for this 2 1, this can be decoded 2 times. This value 2 1 2, this can be decoded 3 times. So for the value 2 1 2 3, actually this 23 falls between 10 to 26. That is okay, that is perfect. If that is the case, we simply do an addition, and if we do an addition and we just find whatever result we have calculated, and we can simply return this. This is a very effective solution. Now what could be the other case? Well, the other case could be that the new value we are adding, that does not fall between this 10 to 26. So suppose over here the new value we are adding, suppose the new value is 2128, something like this. So after adding this new value, this becomes 28. It does not fall between this 10 to 26. Because it does not fall between this 10 to 26, actually we don't need to do addition over here. We simply need to, whatever the route we can make before this element, that would be the only possibility we would be able to decode this one as well, because that I just showed you over here, that over here I was adding a 9, and because I was adding a 9, I was only able to make the new decode paths for these three elements. I won't be able to generate these two values, and this becomes our recurrence relationship, and this actually becomes our dynamic programming solution. Now let's try to solve this dynamic programming programmatically. We know that we care about the two previous elements. So suppose our given input is like 2 1 2 3. We initialize two values before that as 1 1. Say we have these two as 1 1. Now we check at any given location that whether the value we have, does this value with its previous value, does it fall between this 10 to 26? Okay, in this case this 2 does not fall between 10 to 26. If it does not fall between 2 to 26, we just need to take whatever we had from the previous element. So previous element over here we had 1, so we'll just take 1. Okay, now we have this 1. So again we check with its previous element that whether the value falls between this 10 to 26, the value becomes 21. It falls between this 10 to 26. So we do whatever the previous two elements were, we do sum of it. So the previous one element is 1, and the previous second element, this one is also 1. So we do 1 plus 1, so we can put 2 over here. Now we have new element. This falls between this 10 to 26. That's good. So we do sum of two previous elements. Sum of two previous elements is actually 2 plus 1. So we can put 3 over here. Now we have this 3. Now it creates the value 23. Again falls between this. So we can do sum of 2 plus 3, and that becomes 5. And this 5 would be our result. So this is a very important dynamic programming solution. And at any given moment, if we find out that suppose over here we have an value 8. Now this 38 does not fall between this 10 to 26. So it becomes simple that for this pair, the number of ways we can decode this will still be 5, because we'll just take whatever value we have calculated over here. This solution works perfectly fine, and the time complexity for this case would be big O of n, because we only need to do one iteration across all the strings, and the space complexity would in this case would actually be big O of 1. We would be able to complete this in constant space and time, because remember that at any given location we only need to keep track of just two elements. We don't need to keep track of this whole entire array. We just need two starting elements, and we would keep on iterating them over different values. So this is a very good solution. And okay, first of all we will check that whether the first element is 0 or not. If this is the case, we can simply return 0. Okay, so we will create two parameters, 1 and 2, and we will initialize both to value 1. Let's run a for loop. We'll start the loop from first position, and we will go up until the length of the given string. We are running it from I equal to 1 because we already checked for the 0th position. First of all, we create a value current to keep track of the current element, and now we check that if the current if the new character that we are trying to add, if that is not equal to 0, we can assign the value of 1 to current. Now we also need to check that after we are adding the value at ith position, are we getting the 2-digit value between 10 to 26? So first of all, let's create a new variable called value, and we will try to calculate the 2-digit value. We check the condition. So if value is greater than or equal to 10 and value is less than or equal to 26, which means we need to update the current value is current plus whatever the value of 2 we had, because remember the value at current we are already adding it as 1. Now we need to update the values of 1 and 2. So 2 would become whatever the value of 1 we had, and 1 would become whatever the value of current we had. And yeah, I think this would be our solution. So at the end of the solution, we need to return the value of whatever the current value we had. But since we are initializing current inside, we'll just return the value as 1. And let's try to run the code. Oh, we can initialize the current as 0. Let's try to run the code. Okay, looks like our solution is working. Let's try to submit the code. Okay, our solution works pretty fast and pretty efficiently. So I'll be posting the solution in the comments. You can check it out from there.